Some people think mathematics is hard or complex, but when it comes to data analysis, you don't need to be intimidated by complex formulas or complex equations. In this video, I will highlight some key statistics that every beginner data analyst or scientist should know. Hi guys, and welcome back to my channel. My name is Premise AK, and on this channel we talk about data science, machine learning, artificial intelligence, and other technological advancements. If this is your first time seeing me or coming across this channel, make sure you click on the subscribe button and on the notification bell so you'll be alerted whenever I post any new video. Some people think mathematics is hard or complex, but when it comes to data analysis, you don't need to be intimidated by complex formulas or complex equations. In this video, I will highlight some key statistics that every beginner data analyst or scientist should know. These foundational concepts will help you make sense of data, draw meaningful insights, and make informed decisions. Let's begin with what is statistics. Statistics is a science of collecting, analyzing, and interpreting data. It helps us understand or make sense of numbers and make informed decisions in various fields like business, science, and our everyday life. Statistical methods are mainly useful to ensure that your data are interpreted correctly. Let's touch on some concepts, some statistics concepts. There are two types of statistics that we have: descriptive statistics and inferential statistics. We'll begin with descriptive statistics. Descriptive statistics refer to a set of methods used to summarize and describe the main features of a data set, such as its central tendencies, variability, and distribution. Measures of central tendency is also known as the summary statistics that are used to represent the center point or a particular value in a data set or a sample set. We have the mean, median, and mode, which are the three main measures of central tendency used in statistics to describe the data. The mean or the average is the sum of all values divided by the number of values. It gives us a central tendency of the data. For example, if you have a data set of daily temperature of 25, 30, 28, 35, and 22 degrees Celsius, the mean of the temperature would be 25 plus 30 plus 28 plus 35 plus 22 divided by 5, which is 28 degrees. The median is the middle value. When the value is sorted, it is less sensitive to extreme values compared to the mean. So you sort the data and the middle point. So in the same data set, the median temperature is 28. So when you arrange from the smallest to its largest, as is the middle value when you arrange in ascending order. In this case, as the mean and the median are the same, we have a symmetric distribution. We'll get to talk about distribution later on, which means that if a vertical line is drawn at some point in the middle of the histogram, the shape to the left and that to the right of that vertical line will be mirror image of each other. So the left and the right will be the same. It's like you've just cut it into half. Then we have the mode. The mode is the most frequent value in the data set. So if you have temperatures that are 25, 30, 28, 35, 22, 38, 25, 42, 18, 27, and 31, with 25 appearing twice, it is the mode. In a histogram, the mode would be the highest value, the value with the highest bar. The second type of descriptive statistics is measures of dispersion or measures of variability, such as range, the variance, and the standard deviation, which describes the spread or dispersion of your data, how widespread your data is. The range is the difference between the maximum value and the minimum value in the data set. So for our temperature data set, we had the range is 42, that's the maximum, minus the minimum, that's 42 minus 18 will give you 24. Standard deviation. The standard deviation measures the amount of variation or dispersion of a set of number. A higher standard deviation indicates that the points were spread out over a wider range over the mean. Variance is the average of the squared difference from the mean. It gives us an idea of the extent of the data point from the mean value. Example, in a data set of exam scores, a higher variance indicates that scores are more spread out from the average score. So if you have an average, if you have high variance, so you have more spread out value, suggesting greater variability in performance across the group. Distribution. Now let's talk about distribution, data distribution, which describes how data is spread out or arranged across different values. There are different types of distribution. The first is the normal distribution, which is also known as the Regression distribution. It is characterized by a bell curve where data clusters symmetrically around the mean. So you have that bell kind of curve data. An example is weight, height, and many biological measurements often follow a normal distribution in a population. Number two, skewed distributions. Skewed distributions have data that are clustered more on one side of the mean than the other, resulting in a skewed or non-symmetrical shape. So you could have it bent somehow, like you can see on your screen. An example would be income distribution. So when you have income distribution, some people you have the higher class and you have the lower class, and the lower class tend to be more, but the higher class pulls the mean upwards. The third type of distribution is uniform distribution. In a uniform distribution, data is evenly distributed across all values, creating a flat rectangular shape distribution. An example is rolling a fair die or six-sided die that can produce uniform distribution of outcome of 1 to 6. The fourth type of distribution is bimodal distribution. Bimodal distribution have two peaks or two modes, indicating that the data has two distinct clusters or groups. So you have higher values, two high kind of occurring values. An example would be exam score in a class where students perform well and maybe others perform not so well or poorly, which should give you a bimodal distribution that has two peaks. Visual representations like histogram are often used to display the distribution of data, making it easier to identify patterns and outliers. The second type of statistics is inferential statistics, which is used to interpret the meaning of descriptive statistics. It allows us to make predictions or draw conclusions about a population based on a smaller sample of data. Unlike descriptive statistics, which simply summarizes the data, inferential statistics goes a step further. That means once the data have been collected, analyzed, and summarized, then we use the stats to describe the meaning of the collected data. So if you get the mean, what does the mean mean? It is simply used for explaining the meaning of your descriptive stats that allows us to use the information collected from a sample to make decisions, predictions, or inferences from a population. For instance, if you have collected data on the test scores of a sample of students, we can use the inferential statistics to make prediction about the test score of all the students in that class or in that school. Inferential statistics can be classified into hypothesis testing and regression analysis. As a beginner, you wouldn't need to deal with these concepts as much, so I will define them to avoid confusion. We'll dig deeper when you're ready to start throwing hard meats. Hypothesis testing is a type of inferential statistics that is used to test assumptions and draw conclusions about the population from the available data set. Types of hypothesis testing include z-test, a-test, f-test, and ANOVA test. Regression analysis is used to quantify how one variable will change with respect to another variable. That helps us understand the relationship between these variables. There are different types of regression analysis, and the common ones are linear regression and logistic regression. Correlation is another term associated or often associated with regression analysis, which you might come across. So when you plot X, a scatter plot, you want to get how correlatable they are. Correlation measures the strength and direction of a linear relationship between two variables. So for example, you might examine a correlation between the study hours and exam scores. So for example, if you have more study hours, you might have higher exam score. To understand how the study time impact your performance. With correlation, you could have either a positive correlation or a negative correlation. So for positive, it shows that the two variables are related in such that if one is increasing, the second is increasing as well. So you have this line from the origin of your graph straight down, you have a straight line. For negative correlation, you have the reverse in the case, which means that as one variable is increasing, the other is reducing, and you have a kind of a negative slope. You could also have weak or strong correlations. So if you have weak positive correlations, that means it's like you have these lines perfectly aligned along the line. Or if it's weak correlation, it's there but it's not so kind of very clear. Or you could also have weak or strong negative correlation. Finally, we have zero correlation, which indicates no relationship between two variables. In a data set with zero correlation, changes in one variable don't predict any consistent change in the other. The data point appears scattered randomly with no discernible trend, patterns, or direction. In other words, knowing the value of one variable gives no information about the value of the other. An example would be shoe size and salary. There is no logical connection between the two, so if we plot them on a graph, we'll likely see no trend at all. In data analysis, understanding when variables are independent of each other is just as important as recognizing when they are connected. I hope you found this video interesting and insightful, and I hope I've been able to break down some of those complex concepts and you don't see statistics as hard or difficult. Let me know what you think about this video in the comment section. If you have questions, I'll be in the comment section also to answer. Bye. See you on the next one.